Hello and welcome. In this presentation, I'll discuss value stream mapping and how to draw current state map for a company. Now, value stream mapping is a widely used qualitative lean tool that is aimed at understanding waste and then eliminating those waste within the processes. Now, the value is the capability that is provided to the customer, and this has to be viewed from the customer's point of view. This could represent highest possible quality. It could represent providing products at the right time at an appropriate price. So anything which does not deliver these capabilities are non-value added activities that should be treated as waste. Now, organizations use value stream mapping to pursue their lean conversions and go beyond improvement in just one process. So instead of localized improvement events, value stream mapping allows you to have an end-to-end understanding of how all these improvement events come together and improve the set of processes that are linked with each other. Okay, so that allows you to see the waste and then develop a plan to eliminate those wastes. Value stream mapping goes through a certain analysis set of analysis steps. You start with drawing the current state value stream map. Then, using some creativity and lean basics, you strive to develop a future state map. And this future state value stream map is an improvement in terms of the value added activities as a proportion of overall activities that you are conducting within your organization. And then that future state becomes the current state, and that once again goes through iterative process of improvement. So you have the next future stage a state, and so on and so forth. So we'll take this example of a company called Acme Stamping and then understand how we build a current state value stream map for this organization. Now, Acme Stamping Company produces several components for vehicle assembly plants. And this particular case concerns one product family, which is a steel instrument panel bracket subassembly. And this comes in two different types. One is the left hand drive version, the other is the right hand drive version of the same automobile model. These components are then sent to the customer, which is State Street Vehicle Assembly Plant. And the customer requires 18,400 pieces per month. Out of them, 12,000 will be left-hand drive and 6,400 will be right-hand drive. The customer's plant operates on two shifts: palletized returnable tray packaging with 20 brackets in a tray and up to 10 trays on a pallet are sent to the customer. And the customer typically orders in multiples of trays. There's a there's a daily shipment that is going from the Acme Stamping Company to the customer by truck. The work times are 20 days in a month, and there are two shift operations in all departments within Acme. 8 hours every shift with overtime if necessary. There are two 10-minute breaks during each shift, and then it's a manual process that will all stop during this break. And finally, also have unpaid lunch to account for as part of our understanding of the value addition that is going on. Now, if you look at the times, we have 8 hours per shift. So we can actually convert this 8 hours per shift into seconds, because we will see soon as we get into the current state map that we typically look into value added time from lowest possible time units that we can consider. So let's convert that 8 hours per shift into seconds, which is 8 times 60 times, so 60 minutes per hour and then 60 seconds per minute. That gives us 28,800 seconds that they have every shift. But out of these 28,800 seconds that they have, this is in seconds. Out of those 28,800 seconds, you have two 10-minute breaks. Those two 10-minute breaks amount to 2 times 10 times 60. It's so 10 minutes times 60 seconds are the conversion of minutes to seconds, and there are two of them. So this will give you 1200 seconds break. So the remaining time is what's the real time that is available for processes to do anything. So the time available actually is every shift you will have 28,800 seconds minus 1200 seconds, which will give you 27,600 seconds. Right? So this is something which we will see later as we build the current state map. Now, Acme's production process has several steps. First step is stamping, then you have welding, and then you have assembly. Once the assembly is over, the components are then staged and shipped to the vehicle assembly plant on a daily basis. The switching between a left-hand drive and the right-hand drive brackets requires 1 hour changeover time in the stamping process and then 10 minutes fixture change in the welding processes. The steel coils are supplied by Michigan Steel Company, that's your supplier, and deliveries from the suppliers are made to Acme on Tuesdays and Thursdays, twice a week. Acme's production control department receives State Street's 90-day, 60-day, and 30-day forecasts and then enters them to the MRP system they have, Material Requirement Planning System. Then they issue Acme's 6-week forecast to the supplier, Michigan Steel Company, also via the Material Requirement Planning solution software they have. They secure coil steel by weekly faxed order released to Michigan Steel Company. So along with the 6-week forecast that they send to the supplier via MRP, they also send weekly faxed orders to the supplier for how much of the steel coils they will need for the week. They receive daily firm orders from State Street. So State Street also provides you not only the forecast for 90 days, 60 day, and 30 day, but also provides firm orders on a daily basis. The MRP department also generates, or production control department also generates the MRP based weekly departmental requirements. This is based on the customer orders. They also generate work in process inventory levels, finished good inventory levels, and any anticipated scrap and downtime. The department issues weekly build schedules to stamping, welding, and assembly processes, and issues daily shipping schedules to these shipping departments. So they are the ones who are providing information of what to build, how much to make, and how much to ship. Now, for the stamping company, Acme Stamping Company, we also have process level information. So for stamping process, uh, this is a big press that they have, which makes parts for different Acme products, not just the product family that we are currently focusing on, but other products also. It's an automated 200-ton press with coil. Its cycle time is 1 second, which means that it makes products quite fast. It stamps quite fast. So 60 pieces per minute is the speed at which it makes things. Changeover time is 1 hour. Machine reliability is 85%. And the inventory that we observe when we walk through this manufacturing plant is 5 days of coils before the stamping press, 4,600 pieces of the left-hand drive finished stamping after the press, and 2,400 pieces of right-hand drive finished stamping after the press. For spot weld workstation 1, which is dedicated to this product family, it's a manual process with one operator. The changeover time is 39 seconds, and the cycle time is 39 seconds, and the changeover time is 10 minutes. This is for the fixture change that they have. The reliability of spot weld workstation 1 is 100%, and the observed inventory that we see here is 1,000 pieces of left-hand drive and 600 pieces of right-hand drive. Then we have spot weld workstation 2. Again, we have information about the cycle time, changeover time, reliability, and observed inventory. Assembly workstation 1 follows after that. Once again, all the information relevant here, cycle time, changeover time, reliability, observed inventory, is provided to us. And finally, assembly workstation 2. Also has information about their cycle time, changeover time, reliability, and observed inventories. Finally, the finished goods that we have built after assembly workstation 2, they go to the shipping department. So shipping department removes parts from finished goods warehouse and then stages them for truck shipment to the customer. So now we're going to draw the current state value stream map for this company. The first step will be to show the customer. So the customer is State Street Assembly. We show that in the right hand side of this figure. Also, we show how much the customer demands on a monthly basis, which is given to us as 18,400 pieces per month, with 12,000 of them being left-hand drive brackets and 6,400 of them being right-hand brackets. The tray of 20 pieces, and then these trays are then put in the pallet, and that's the way the shipping is done. So we write that specification information also in the information under the customer, and there are 2 shifts that they operate on. The next step will be to add the major processes that are provided to us in the given situation here. And what we do is we present these processes in rectangles here: the stamping, spot welding 1, spot welding 2, assembly 1, assembly 2, and shipping. And under these processes, we have information about the data that we have. So for each of them, we've been given about information about their cycle time, changeover time, their uptime. And this is where the seconds available is indicating how much time is available for this process to do things. And we did the calculation in the previous slide of 27,600 seconds are available in every shift after we take out those 2 10-minute breaks that exist there. Okay, so that's the idea of 27,600 seconds available. And the last point here is EPE, which stands for every part, every 2 weeks. So the stamping press, since it's making different products for Acme, not just the product family that we are focusing on here, the way it works is that it's a very fast machine. So every part gets to be made after every 2 weeks. They have to wait for 2 weeks. So there's a big batch of part that is being made. And then it comes back to that part after 2 weeks. So the triangles now, what we see here are the inventories that exist. So the first triangle before stamping is the triangle representing 5 days of steel coils that came from the supplier. And then all the triangles that we see between the processes are the work in process inventories between 2 workstations. So that's all the information that we see from the given information from the case. So 4,600 left-hand drive and 2,400 right-hand drive is the inventory between the stamping press and spot weld 1, and so on and so forth. So essentially, everything that you see at the bottom, they all represent the data that was given to us. For everything, we have information about cycle time, changeover time, the uptime, which is reliability, number of shifts, and how many seconds do we have every shift to work on that process. So that's the information that we see for all of these different processes. Okay, so that's what I'm noting here. And then after that, we also have information about all the inventories. So those are the triangles that we see between the processes. So all that information will become relevant as we start looking at value added and non-value added time within the system. So that was our second step. So inventory triangles are there, all the processes are presented now, and all the data boxes are also there. The next step would be to show the material flow from the supplier, which is Michigan Steel Company, to Acme Stamping, and within the company also, from the company to the customer. That is what we are showing here. So the supplier of raw material is identified with the factory icon that I just showed, Michigan Steel Company here. And they deliver 500 feet coils on Tuesdays and Thursdays to Acme. So we are showing it over here with this arrow, a dark arrow, which indicates that this is being sent through truck. And it's the finished goods, at least from supplier's point of view, it's their finished goods that they're sending to you. And From Acme's point of view, the shipment of the daily shipments that we see here is also finished goods going to the customers, again, using trucks on both sides. So that's how we are trying to show the way products come in and the way products go out of this company. The next step will be to show the information flow, because in supply chain, we don't only have material flow, but also have information flow. And that information flow is drawn from the right to the left, from the customer to Acme, and from Acme to the supplier. And this is shown at the top half of the map that we had built so far. A solid line arrow would indicate that there's a paper transfer. Information is transferred through fax or some paper-based communication. And an arrow with a lightning bolt is representative of an electronic transfer. And then we also will show material movements. And in this particular case, it's a push-based environment because the the production control department, is sending specified schedules and forecasts for each processes to work on. So every process basically produces, regardless of the needs of the downstream customer, they have their own forecast that they're working on. And this is essentially a guess of what needs to be built. And these are built in large quantities with a certain batch size. So to show that it's a push-based system, we will use striped arrows between the processes. So here is some more thing we will need to do before we get to understand exactly how the flow is. We also want to show the timeline, which is how much of value added time and non-value added time exist in this system. So we, for example, have already accounted for the processes. We have accounted for the information flow and the material movement so far, at least. That's what we want to do. But then we also want to understand, with all that push-based system and the way the information flow is happening, how much of the value-added time and non-value-added time is accounted for within the processes. To do that, we have to understand what the production lead time is, which is the time it takes for a part to make its way from the shop floor, beginning with the raw material. And then we also have to account for the inventory lead time. So under every inventory triangle, we have to show how much time this inventory is expected to stay in their system before it goes out, because that would also be a lead time which we have to calculate. Now, inventory lead time can be calculated by taking the inventory quantities that are there in a triangle or just under the triangle, and then dividing it by the daily customer requirements. So that's what we were going to do. We're going to do in the next step here. So this is the current state map, which now has also information about information. The information flow is also shown here, and we are showing the push-based system. So we see that this production control department receives 90-day, 60-day, and 30-day forecasts from the customer, and it's electronically coming to them. We also receive daily orders from the customer. That's also electronically received by the production control department. The production control department in turn sends 6-week forecasts to the supplier, Michigan Steel Company. That's through electronic means. And they also send a weekly fax to Michigan Steel Company for the weekly requirements. And then the other job that MRP does is sending all these forecasts to individual departments. So on a weekly basis, every department receives what they have to build for that week, right? So this is how the MRP is sending signals to stamping, spot weld 1, spot weld 2, assembly 1, assembly 2, and shipping. And this again provides us information about how everything is being built in the organization. These striped arrows that we see here, these are the ones which represent that we have a push-based system between the processes. So that indicates that everybody is building on their schedule, and hence there's a push-based system between the processes. Now the timeline is denoted below under the blue line that we see here. So we can see that there are 5 days worth of steel coils that are sitting before the stamping operation. So we put that 5 days under that blue line as the time that it's sitting there. It's inventories of coils. Then under the stamping, we note how much is the process time or the time it takes to actually complete that stamping press activity. And that's the cycle time, that is 1 second. So we put that here. And likewise for all the process steps that we have here. So spot weld number one is 39 seconds. So that's your cycle time. For spot weld 2, 46 seconds, the cycle time. 62 seconds for assembly 1 and 40 seconds for assembly 2. So all that number comes from the data box. The next is to convert the inventories that we have between processes into corresponding inventory lead time. So we saw in the previous slide that we can convert that inventory lead time into, we can get the inventory lead time by using the quantities and dividing it by the daily customer requirements. To understand what the daily customer requirements are, so let's look at what the daily customer requirements are. Daily customer requirement will be how much they are demanding on a monthly basis, which is 18,400 pieces, and then dividing it by the number of days the companies are operating in a month, which is given to us as 20 days. So the daily customer requirement is 18,400 divided by 20, which gives you 920 pieces. So 920 pieces has to be built on a daily basis. So now if I were to convert the inventories that exist between stamping and spot weld 1, I can first determine how much the inventory quantities are. So that is 4,600 plus 2,400. The sum of that comes to 7,000 units. So 7,000. And that has to be divided by your daily customer requirement, which is 920. Right? So this 7,000 divided by 920 will give you 7.6 days. That 7.6 days is what you see here as your inventory lead time between stamping and spot weld number one. So that inventory is going to sit there for 7.6 days. And likewise, we could do that for all the other inventory information that we've been given between the process steps. Right? So that's what we see in these numbers. So now we have information about the process times, which is the cycle time for each of the process, and also inventory lead times between these processes. So that's all the information that we just calculated. So using the information that we just calculated, what now we're going to do is we're going to add all those numbers that we have situated on this top line. So this top line basically indicates the inventory lead times, and that is 5 days. That is here 5 days plus 7.6 days plus 1.8 days plus 2.7 days plus 2 days plus 4.5 days. That totals to this 23.6 days. Okay, so that's your total production lead time, because we were to add these seconds also, but these are hardly any time that we have to add. So the process times are not really contributing anything substantially in terms of the time that is happening for the inventory lead time. So even if we add everything which is in the process time, which is 1 second and 39 second, 46 second, 62 seconds and 40 seconds, and then add that to 23.6 days, it still will be pretty close to 23.6 days, not too much of a difference. So the process, the production, the overall production lead time is 23.6 days, including all the times that we have for inventory lead time and production lead time, and or the process time, sorry. And what we have on this lower uh, lines are the process times only, not with the inventory lead time. So that totals to 188 seconds. So that 188 seconds is your process time, and 23.6 days is your production lead time. So there is a big disparity in terms of how much is the actual value added time, which is 188 seconds, and how much is your non-value added time, which is about 23.6 days. And this disparity is what you are able to visualize by creating this value stream map. So overall, this would be your complete view, which captures uh, your customer, your supplier, your own organization, and the product flow within the organization, the product flow from your organization to the customer, from the supplier to your organization, and also the information flow from the from the customer to the production control department, and from production control department to the supplier. Finally, this particular view also shows us the value added and non-value added time, which then helps us understand how we can initiate process improvement within this organization to make the future state better than this. So overall, this presentation highlights what is value stream mapping and how to draw a current state map for an organization. Thank you.